All right, welcome back. This will be part two. This is section 2.3. We just got done talking about what a function is, how you tell if it's a function, what you're looking for to tell if it's a function or not. And so this part, talking a little bit about some of the other things that go with dealing with functions. All right, so two terms here. You got domain and range. Okay, domain of a function is a set of all possible values of the first variable. Basically means all possible x values. The range of a function is a set of all possible values of the second variable. So all possible y values is what you're looking at for the range. Again, usually x's and y's, especially when you're talking about plotting points, x-axis and y-axis. So the domain is the possible x values for that function. The range, possible y values for that function. So now looking at this example here, got a couple different pictures. Looking at the chart here on the left, the domain. We can usually just put a capital D, colon, and then in this kind of thing, we just have a bunch of points. And so what we're going to do is write a set of numbers. And we put this squiggly bracket, I don't know what it's called, but what are our x values? We've only got a couple, 2, 4, 6, and 8. And the squiggly bracket, that's our domain. Those are the possible x values that this function has. The range is the possible y values. So same thing. We just got a few of these points. Our possible y values, 2, 3, 4, and 5. And the squiggly bracket. There's your domain and range. All right. For this second graph, the one in the middle, you just have points. Okay? These points are not connected by a line. You just have points. And so kind of the same idea as the table that we just looked at. The domain, possible x values. We have an x value at -2. This point has an x value of 0. This point has an x value of 1. And the last point up here, we're at an x value of 3. That's all the points we got. Those are all of our x values. The range, kind of the same idea. We're looking at the y values. For the first point, we got a y value of -2. At this point, we got a y value of 0, y value of 1, and for this point, a y value of 3. And there's our domain and range for that function. Okay, just a series of points, so we're just writing it as a set of numbers with these squiggly brackets. In this last drawing on the right, now we have a ray. Our graph starts at this point and goes on forever with that positive slope. So for our domain, the possible x values, well, the lowest x value we have is here at -1. And then this graph just keeps on going up forever. That means these x values are going to keep on going off to the right. So what we have is x values greater than or equal to, because it's a solid, we're including that -1. And we have all the x values greater than that. That's our domain. For the range, kind of the same thought process. The smallest y value we have here is at -3. And this graph goes up. So we've got all the y values greater than or equal to -3. That's your domain and range for this. All right, a couple of different types of functions. Take a second, hit pause, copy these things down. For a discrete function, it's basically just looking at a set of individual points. This is the same graph we just had on the last slide. It's just points. That makes it, as long as it's a function, one x value to exactly one y value, a discrete function is just a series of points. That's all it is. You're not connecting them with anything. It's just points. A continuous function is a graph that is a line, ray, segment, or a smooth curve. That's what you're used to dealing with most of the time. Could start anywhere. As long as all the points are connected with some sort of line fragment or a smooth curve, that's a continuous function. And that's all you're really looking for. Again, just some terminology. Okay, last thing, big thing, function notation. Boy, looking at this, I really don't like that purple. Sorry if it's hard to read. Function notation is this. Y equals f of x. It's just another way to write it. You know, we're used to saying equations, y equals mx plus b, that kind of stuff, y equals x squared. F of x and y are the same thing. They are interchangeable. The f of x, that's how you read it, that's called the function notation. Basically, f is just the name of the function. Your independent variable, or the first variable, that's just what the equation is in terms of. And so in this example right here, you can see we have f of x, it equals, and then you've got this equation that has just x's in it. Okay, this is your function notation. So how it works, if we want to evaluate a function at a certain x value, you just write it. This is function f. We're looking at what does this function equal at an x value of 1. And so wherever you see an x value, you plug in 1. And then you just use your order of operations. So 1 squared is 1, so we got a negative 1.2 plus 4 minus 3. That's 1. So we got that. That becomes a negative 0.2. And so this is what f of 1 is. Now again, this function notation, this is your y value. So what we're looking at is this point. We had an x value of 1. Our y value is negative 0.2. Okay. For the x value of 5, it works the same way. The function f at an x value of 5. Wherever you see x, plug in 5. So negative 1.2 times 5 squared plus 4 times 5 minus 3. All right, negative 1.2 times 25. Just do an order of operations. Oh, 1.2 times 25. Let's see. 1.2, that's a negative 6/5 times 25 over 1. We get negative 30 plus 20 minus 3. And that puts us at a negative 10, negative 13. And so what we're looking at, the function f at an x value 5 equals negative 13. Just a point. X value 5, y value negative 13. That's function notation. Plug in the name of the function is this letter. You plug in a certain x value, it gives you the y value. Okay. Go ahead, hit pause. Try this problem out on your notes. We'll talk about it first thing in class. Have a good night.